Hey Tech Geeks! In this video we will learn what object-oriented programming is, why it matters, and how it helps make coding easier and smarter. Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you. Let's dive right in. Imagine you're playing a video game. You have a character. That character has powers, health points, and weapons. You can make the character jump, run, and fight. That character is just like an object in object-oriented programming, or OOP for short. OOP is a way of writing computer programs by thinking in terms of real-world things, like characters, animals, cars, or anything else that has properties and can perform actions. These real-world things are turned into code and we call them objects. Now let's break it down step by step. So, what is object-oriented programming? Object-oriented programming is a way of organizing code so that it's easier to build and manage. In OOP, we create objects. An object is a unit of code that contains data and functions that can work on that data. Data is called properties or attributes, and functions is called methods. Let's take a dog as an example. A dog has properties such as name, color, breed, age. Methods include bark, eat, and sleep. In OOP, we turn this idea into code. We can say, let's create a dog object, and we give that dog its own data and actions. This makes our code more organized and easier to understand. Why do we use OOP? Before OOP, programmers used a style called procedural programming, where everything was written as a long list of instructions. This worked for small programs, but when things got bigger, it became confusing and hard to manage. OOP solves this problem by organizing code into smaller, reusable pieces. It helps us avoid repeating code, keep things neat and clean, work in teams more easily, fix bugs faster. 4 pillars of OOP. To understand OOP better, we need to learn its 4 main ideas or pillars. These are encapsulation, abstraction, inheritance, polymorphism. Let's explain each one in a simple way. First, encapsulation. Encapsulation means keeping the data and methods that belong to an object inside that object. Think of a capsule. It keeps everything sealed inside. For example, when you use a phone, you tap a button to take a photo. You don't see the code or how it works inside. That's encapsulation. You only see what you need to use. In OOP, we hide complex code inside objects and give the user only what they need. This makes programs safer and easier to use. Second, abstraction. Abstraction is about showing only the important stuff and hiding the rest. Think of a car. You use the steering wheel, brake, and gas pedal. You don't need to know how the engine works to drive. That's abstraction. In OOP, we create simple ways to interact with objects without showing every detail. This keeps things easy and clean. Third, inheritance. Inheritance means creating a new object that is based on an existing object. Imagine we already have a class called animal. Animals can eat and sleep. Now, we want to create a dog class. Instead of writing the eat and sleep methods again, we let dog inherit these from animal. This saves time and avoids repeating code. We can also add new things to dog that are not in animal, like bark. Fourth, polymorphism. Polymorphism means many forms. It lets us use one method in different ways depending on the object. For example, we have a method called makeSound. If we use it with a dog object, it barks. If we use it with a cat object, it meows. Same method name, but different behavior. This makes our programs flexible and easy to expand. Classes and objects. Now let's talk about 2 important terms in OOP, and that are class and object. A class is like a blueprint. It defines what the object will look like and what it can do. An object is the actual thing created from that blueprint. Let's take a class called car. The car class says it has properties like color, brand, and model. It can drive, honk, and brake. Now we create objects from this class. For example, car 1 equals red Toyota Corolla. Car 2 equals blue Honda Civic. Each object has its own data, but they come from the same class. Real life example. Think of a school. We can make a class called student. It has properties like name, age, roll number, methods like study, take exam. Now we create students. Student 1, name equals Alex, age equals 14. Student 2, name equals Sarah, age equals 13. They both study and take exams, but they have different names and ages. This is OOP in action. By the way, we offer multiple services on our website, and IT-related courses are one of them. And in our programming-related courses, we have also explained object-oriented programming really well. Make sure to check out our website and stay tuned. I'm mentioning the link in the description box. Benefits of OOP. Object-oriented programming has many benefits such as reusability of code. Once you create a class, you can reuse it anywhere in your program. This avoids writing the same code again and again. Improved organization. OOP keeps your code neat and clean by grouping data and related functions into objects. This makes large programs easier to manage. Easier maintenance. If you need to change something, you can update the code inside one class without affecting other parts. This saves time and reduces errors. Real-world modeling. OOP helps you think in terms of real-life objects like cars, animals, or users, which makes it easier to design programs. Team collaboration. In a team, different people can work on different classes or objects at the same time. This speeds up development. Better security with encapsulation. By hiding data inside objects and only exposing what's necessary, you protect your program from accidental changes and misuse. Flexibility through polymorphism. You can use the same method in different ways depending on the object. This adds power and flexibility to your code. Limitations of object-oriented programming. On the other side of the picture, the limitations of object-oriented programming include: first, steeper learning curve. Object-oriented programming can be difficult for beginners to grasp. Concepts like classes, objects, inheritance, and polymorphism may feel confusing at first, especially for those new to programming. 2. Not ideal for small programs. For very simple tasks or small programs, using OOP can be unnecessary and overly complicated. Procedural programming might be a better fit in such cases because it's quicker and more straightforward. And third, slower execution in some cases. OP can sometimes lead to slower program performance due to features like dynamic dispatch, object creation, and abstraction layers. While the difference may be small, it can matter in performance-critical applications. 4. Increased memory usage. Creating multiple objects, especially with deep inheritance structures, can consume more memory compared to simpler programming styles. This can be a concern in memory-limited systems. 5th, risk of over-engineering. Developers might overuse OOP principles, creating too many classes or unnecessary complexity. This can make the code harder to read, maintain, and modify if not managed carefully. Object-oriented programming in everyday programming. Many popular programming languages use OOP, including Java, Python, C++, C#, JavaScript. Even apps and games on your phone use OOP to run smoothly. For example, a game might have classes like player, enemy, and weapon. A shopping app might have product, cart, and user. Each of these is an object doing its job. So, in short, object-oriented programming is a way of writing code using objects. It helps make programs easier to build, manage, and grow. The 4 main ideas of OOP are encapsulation, abstraction, inheritance, and polymorphism. Classes are blueprints and objects are the real things created from them. Object-oriented programming is used in many programming languages and real-life applications. If you understand objects and how they work together, you have already taken your first step into the world of object-oriented programming. Keep practicing and you'll get better every day. I'll see you in the next video and let's keep learning together.